Josh Bassett.
I'm Wyatt Allison.
Martha Dorn.
America Zelchi.
Houston Wade, and we're from Shortline School in Wetzel County.
Our project is on energy. And following in the path of the scientific method, we came up with a question to start our process. We asked, can a lamp in a solar panel continue to power itself? We tried several failed attempts to get the lamp to power itself. And in the final sad attempt to save our project, we switched questions to how does a different wattage of a bulb and a distance from a light source affect how much power a solar panel can produce? And our hypothesis for that was that the LED would have more energy than the rest of the bulbs.
We came up with some interesting results. One result is that in the brightest bulb produced in your eyes, the brightest bulb produced one of the lowest amounts of power. The LED light, as we learned, produced more light and less heat, making it more energy efficient. That may be helpful for the environment, but was shocking for our experiment. Another thing that we noticed is, in general, is that when the solar panel was moved back, we got less power. This showed that the solar panel could not pick up all the energy from further distances.
The one bulb that produced the most energy was a soft white 60-watt bulb. We thought that because of the soft color of the bulb, the DCV, or direct current voltage, I think I got that right, would not be as high as it really was. But out of all our samples, the hardest to collect was the sun, because there is only one distance and you can't touch the sun to get any samples. And plus, with the weather that we're having, it's not really out right now. From our one distance from the sun, it came up to be 5.13 dCV.
Now, you might be wondering how we set up our experiments to measure all these facts and charts that we're giving you. But to tell you the truth, the experiment was rather easy to set up. First, we took 2 lamps and we started with 1 LED and 1 40-watt. Then we took our measurements.
Next, we exchanged one of the bulbs with a 60-watt bulb, and we were faced with a problem. How are we going to get a control subject or a sample from the sun that lines up with the distance that we need?
So we decided to just take 2 different samples of the sunlight. We took one inside and one outside to see if the windows had any effect on how much DCV it generated. And in fact, the windows did have an effect, and outside it ended up being 0.14 DCVs, higher than inside. And as a conclusion, we can see that the 60-watt bulb makes more DCV than the sun, coming in second at 5.13.
Is that all?
We're going to just explain the charts.
Please, no, go ahead.
Wyatt did his own little experimenting. Would you like to explain?
Okay. When you double the distance from the light bulb, it decreases by a factor of 4. Like at 6 inches, we had 270. At 1 foot, we had 250. And we did 6 inches again, but it came up 300 because the sun was out more outside than we were in a controlled environment. And at 3 inches, we got 630, and then 6, we got 300. It wasn't accurate because of the light we had. We should have been in a dark room, controlled room. But the 60-watt touching produced more heat more power than the sun, not heat, from where we were testing. A small solar panel cannot produce enough power to light a light bulb.
Well done. Yeah. Okay, questions, guys. So you were mentioning some numbers there, but those aren't DCVs, right? So
Them are lux.
those are lux. So what is lux?
What did you research?
It's some, I
Is
have
it-
it on the paper, but I don't have it.
Okay. Is it a measurement of brightness?
It's a measurement of, I'm pretty sure it's a measurement of how bright the light is.
Good.
but I'm not real positive.
Okay. Other questions? So you talked about the sun, you talked about distances that the lights were from where you were putting the solar panels. Why do you think that when it was further away that you weren't getting as much energy, and something as hot and as huge as the sun, you know, why would you think that that would not be generating as much energy as say a light bulb?
It's like a flashlight. The farther away you are from a flashlight, the harder it is to see. So it produces less light the farther you are.
And on top of
It
that,
takes more energy to travel that distance.
we were using a small solar panel, and because of the size, it didn't really pick up as much of the light as it could. And solar panels can't pick up all the light anyways.
So you mentioned the flashlight. So is it that the light just disappears, or is it that it spreads out?
It takes more energy to travel that distance.
Okay. So it's not as concentrated. Okay. Other questions for these guys? Okay. Thank you guys very much.